Hey everybody, John Grimsmo here, and on last week's Wednesday video we talked about a heat treat setup and a lot of the improvements that we want to make to that heat treat setup. In this video I want to do those improvements, so let's do it. We're going to install the new pump. I'm going to show you hand lapping, diamond lapping of the aluminum quenching plates, the new ones. They're sick. We're going to install the filter. What else are we going to do? The chiller. And just start picking away at some of the improvements. Let's start by lapping the plates. This is my hand lapping setup. That's our machine lapping setup. We're not going to use the machine. We're going to use the hand laps. So let's talk about that. Okay, so here we have our old and new style aluminum quenching plates. This is how you suck the heat out of the blade immediately after it comes out of the oven. The old style has big cooling channels that go like this. The new style has smaller cooling channels that go side to side, and also has these clever little indents on the side and bumps in the bottom to create turbulence. You don't want laminar flow, you want aggressive, like turbulent flow to help suck some of the heat away. The other theory was maybe we're trying to eliminate warp in every step of the process as much as we can. We're currently quenching like this. Maybe as the cold water comes in and becomes warm water, it's creating, warp this way, whereas in the new way, we're having cold water come in, and if anything, it'll curl this way, but I think that'll be less of a problem than curling this way. So that's one improvement. These were made by my buddy Easton Bednarek from Mariah Manufacturing. He did a killer job. They're 7075. They're fantastic. Really extremely well machined on a Speedio, by the way. Not on our Speedio, but on his Speedio. There it goes. Anyway, he's got a Speedio too. Excellent finish. We're going to put it up on 3 points, and we're going to measure it for flatness over the whole surface. And then we'll talk a lot about flatness. But he got a great finish with this. I mean, look at that. But is it flat? Here we have our granite surface plate. I can put the old one away. I don't need that. So these are 3 devices that Pierre actually made many years ago. They just got a ball bearing on top. They're threaded, adjustable, kind of lap flat on the bottom. So 3 points makes a triangle, 3 points makes a tripod, 3 points makes a kinematic base. Everything can balance kind of on 3 points mostly. So if I put this on 3 points, all right, it is on 3 points. I'm going to take my indicator with a 10th indicator on the tip, and I'm going to come over. See if I can get closer here. Okay, so what I want to do is I want to position the indicator on top of the ball. And then I'm either going to move this up or down to get 0, or I could rotate the dial, or I can tap it, make sure it's settled. So I'm just unscrewing the lower foot right now to get it to be pretty much 0. So now it's 0 over that foot. Now I'm going to come over to the second foot, and I'm going to 0 it again. Okay, now it's at 0. Then I'm going to come over to the third foot. I don't know if I can reach it from this position. So here's what we got going on. We got the piece on 3 points, and I have the indicator zeroed on top of this ball, and then if I slide it over to be roughly on top of this ball, we're at pretty much 0. And if I go over here to this ball, we're at pretty much 0. Within a 10th, I'm just playing around here. And now what I want to do is I want to sweep towards 0, and I want to watch what the indicator does towards the center of the part. Okay, it's going -1. Down here, we're at 0, that's good. Back to where our ball is, I bump the other part. Back to 0 here. So this plate is actually like silly flat. 3/10. 3/10 down in the middle. Maybe 4 over here in the corner. Back to 0 where that foot is. So this kind of lets you, quickly and visually scan the surface and try to see where the dips and the deviations are in your surface. So honestly, 3/10 is incredibly flat coming off a CNC machine. Let's see if we can do it better. So here I have a sample that I've already lapped. Not bad. Funny thing is, this one also still has 3/10 of bow in the middle of a lake. You know, it's a hill or a lake. Little bit of a 3/10 dip in the middle. Let's see if we can get that out. So diamond lapping is something that we've been doing for many years for our knife blades, letting us achieve this incredibly flat, incredibly shiny finish. All those micro scratches are so minuscule, it's not even funny. And it's a mirror. And this is how you get stuff, what they call optically flat. And if we have time, I'll show you what that means too. So I want that for my aluminum plate. The goal for this plate is not to be shiny, not to be a mirror or pretty or anything like that. It's just to be flat. I want that 1/10 of bow to be out of there so that the blades that we're quenching we can eliminate as many variables as possible for flatness. So let's try. Okay, so what I did is many months ago, I made these cast iron lapping plates. I milled them on the Speedio, put grooves on the side, engraved our logo, some dates, some information. I paint filled it with nail polish. They turned out really good. And there are several great videos on YouTube on how to make these and how to dial them in and how to rub them together and how to get them perfect. So then we have something like this. This is our diamond lapping film. And you can see the diamonds have settled to the bottom. Less so on the red one. So blue for 15 micron, red for 30 micron. That is the size of the diamond particle. And then you put it into your plate and it embeds into the surface. See how this one's all black? So there are diamonds stuck to this. And it's theoretically an extremely flat surface because of the way I made it, so that you rub a part on it and it starts to cut your part because the diamonds are stuck in there like little fingernails sticking out. So I have a 3 micron, I have a 15 micron, and then the thing is for aluminum, you actually want your lap to be softer than the part you're cutting, but aluminum is very soft, and cast iron is harder than aluminum. So I took this excellent trick from Robin Renzetti. Give me a second. This is HVAC tape, air conditioning, ventilation, whatever tape. I get it from McMaster, super cheap. It's thin, thin, thin aluminum foil that is sticky. So what I did, based on what he did, check this out. So I made 6-inch plates and I made 8-inch plates, right? I took the 8-inch ones and I stuck on that aluminum foil, and then I lapped them. I lapped them flat, so that now the diamonds are sticking into the aluminum foil, which is theoretically softer than the aluminum part itself. And boy, let me tell you, it worked great. So now, I mean, when you put aluminum foil on a plate, it's no longer like flat, but I lapped them together and generated a pretty flat surface. Maybe there's room for error here, absolutely. Maybe the surface of this is not super flat. I have ways to measure it. I haven't really gotten into it too much right now. I'm just playing around. But in using these plates and lapping this part, I still can't quite get the bow out. So I'm struggling with that. So I'm gonna glove up because you don't really want aluminum in your body. So it's funny because this is not a lapping video, but it's gonna talk a lot about lapping because flatness. So I've already embedded 30 micron diamond into these plates, but they've been out for a little bit. I washed them down with Windex, got all the schmutz off. So then you have your lubricant here, which is the liquid that this is floating in, but this has diamonds in it. The lubricant is the same liquid, just no diamonds. So I'm gonna wet these down again a little bit. Not too much, not too little. And then I'm gonna be able to play. You want it to float nicely, not stick, but not be too slippery. And I'm kind of got this stick slip going on right now. But I can already tell that the plates are starting to get dirty. Yeah, maybe, I can't tell, more lube or less lube, I don't know yet. But it's cutting. I can already see like blackness starting to form there. So those 30 micron diamonds are in there. They don't really go away. So while I'm not new to lapping, we've had our lapping machine for 5 years now. I'm relatively new to hand lapping, and there's definitely some skill and technique involved. You know, some people say figure eights, some people say no figure eights. Most people that I've seen are saying at least use the entire plate so that you're not just wearing a little hole into your figure eight section. So I'm just kind of going all around, going over, trying to make it even. I'm by no means an expert on this, but I'm certainly fascinated by the process. And like I said, I've got some stick slip going on, so I'm having trouble doing smooth, even strokes. But you can tell it's turning black. So what I have heard is that, especially when you have your two plates and you lap them together, is that technically the top plate is always going to be concave and the bottom plate is always going to wear convex. We're talking millionths of an inch here. But I'm wondering if that's happening with my part as I'm lapping, is that the part is becoming concave and the plate is staying flat or convex. So I'm wondering if I should flip this stack around and have the plate on the bottom and the stone on the top, or the lap on the top. I haven't seen people do that before, but I'm kind of curious if it'll achieve the goal here. I don't know. So you want to kind of rotate your part, you want to keep it moving, you want to get it all around, you want to traverse the whole surface. Yeah, I'm going to flip it over and see what I can get here. And then the only way to check, I've got two ways to check. Go back to the 3-ball method and scan the whole surface, or we can use our optical flats and check for flatness that way as well. So we will eventually do both. But you can see the goop, it's cutting. So I've already cut the whole surface. It's all like clean and lapped right now. It's just not flat enough. And these cast iron plates aren't exactly light, especially the 8-inch ones. All right, let's try this upside down. Maybe, there might be something to this. I'm gonna try to focus without tipping the plate more on the outsides, because I want the outsides lower. I'm gonna rotate the lap every now and then. All right, let's try that. Pull it off. It is wrung to this surface. Okay. Let's clean this off, we'll measure it. For cleaning, simply hot soapy water works really good. Now because it's aluminum, it's gonna suck up that heat, so you gotta be careful measuring it after it's like hot. It might change dimensionally, so I'll play with that. Okay, I'm gonna take this other plate off. Feeling for cleanliness, yeah, it's clean, I washed it. And it's still cold, so that's good. So I'm just gonna set it on 3 points and then dial it in like we did last time. All right, so all my 3 points are perfectly at 0. So let's scan to the middle. I've still got -3. Okay, so that didn't do anything. So that's what we're looking at, 3/10. This is a 1/10 indicator. I mean, it's a very, very, very minuscule amount, but it still bugs me. So we'll take this over to the optical flats over there, and we'll see real quick what that looks like. But I think I'm gonna put a pause on that, and I'm gonna start lapping this one, which also has 3/10, but at least I can get through this surface and make it all nice, flat. While my sodium light bulb is warming up right now, it takes about 5 minutes. It's a good time to talk about every aspect of this video could absolutely be its own whole in-depth deep dive video, especially these monochromatic light sources. And I want to, and I probably will at some point. But for now, this video, let's just burn through everything. Let's do a project. Let's use all these cool tools, talk about them briefly, and we'll use them in practice. So remember, I'm using a 30 micron diamond, and it leaves a very good finish, a reflective finish, but it's not shiny enough. So I'm going to take my stones from Spencer Webb at Kinetic Precision. These are precision ground flat stones, not just your everyday stones. Oh, that sounds gross. That's got dirt on it. There we go. So you rub them together to clean them off, make a nice fresh surface. These are not abrasive stones anymore. These are precision ground flat stones. That can be its whole video. But what I'm going to do is I'm going to rub it on this surface, and as long as I don't have any grit or contamination, I should be able to shine this up quite noticeably, which will let the optical flats shine better. As they say, the stones reveal all the secrets. So I can actually see this line right here? That's a face milling line that hasn't fully lapped out yet. Doesn't matter, but it's something, it's still there. All right, here we have my two monochromatic light sources. This one's got a sodium bulb in it, which is primo ideal. I'm not gonna get into it. I'd love to talk more and more about it. But what we're looking for, we're using a single wavelength of light to basically measure the light gap between this flat piece of glass and your part. And I've got it here on a gauge block. This is what ideal looks like. See if I can get it to shine. There you go. See how the lines are extremely straight and extremely parallel. The spacing between them doesn't matter for now. But we have straight, very crisp lines. So can we even see, I can see, can you see on camera what's going on here? Because this is a 30 micron finish and this is like a 1 micron finish, it's not as clear. I don't know if you can see it through the camera. Anyway, what I'm seeing is I'm seeing concentric rings there and there and there. And if this were a finer micron, shinier surface, you'd be able to see it better. And as you play with the light and as you move it around and as you tilt it, you can see the bands changing. They just don't show as well. Anyway, what I'm able to tell with this, there you go, you can see bands there. There, maybe they're just kind of faint. But that's where the expertise, experience comes in. You get to know. So I'm able to see with the light bands that there's an actual dip in the middle and it's high on the outsides. And I've got some cheat sheet charts that kind of show there's more to it, but what each kind of light band means, we'll get into it in a future video. But for now, just know it's a really cool technology. Old school technology too. But that tells me it's not flat. It's flat enough to show bands, which means it's, you know, tenths flat, but not zero flat. Not as flat as a gauge block. All right, next up, the uncut one. Amazing finish, but you can see in the reflection that it bends the light in different ways, right? Which means it's not a super flat surface. There's some specularity to it. It's good, but let's get it better. Because this one has a much more evenly reflected surface. You see like full details, no lines, no bending of light. It's better. Even if it has 3/10 of bow, and this one also has 3/10 of bow, let's at least even it out. Okay, let's time lapse this thing. Clearly, I had a massive piece of contamination, just scratched the crap out of my thing. And I also lost a piece of the adhesive tape right there, but that's yesterday's problem. This just happened now. I don't like that. All right, massive downside to the tape is it likes to let go. I just did that, created that big old scratch, those swirls, and I lost a second section here, that section right there. So that's raised up, no longer flat. Crap, this is not going my way. I think I'm probably at the point where I need to peel these off and put new tape on. No big deal, just some time. I don't know if I was rushing or something, but I'll do that. Oh, this is actually a good lesson in manufacturing right here, where you know, you have all the tools and you set out to do one thing, and that one thing doesn't work, and then you have to keep trying and fixing, and now I have to fix my lapping plates to be able to lap the thing, and then it's just like this snowball of extra work to be able to do the one thing you set out to do. That's manufacturing in a nutshell. I love it. So now I got to clean these plates off. There's still glue residue on them. As I'm trying to scrub all this glue off, I'm definitely wondering about the awesomeness of this idea or not, because this glue is in there. Now it's in all the cracks, and I'll have to pick it out, and I'll have to wash it again and again and again and again. It's not as fun as it sounded like originally. I still think it's a good idea, because you have this sacrificial layer of aluminum on top that you can just peel off and throw away, but just leads to more work. Okay, I've spent almost 2 hours playing with these, getting them better. Getting the glue off took forever because it gets stuck in all the grooves. I had to use toothpicks. It was not fun, actually. If I were to put the aluminum foil onto more plates, I wouldn't put it on a grooved plate. I would put it on a flat plate, like the back side of this or something. Way easier to clean off. So I chose not to put the aluminum foil back on. Instead, I chose to use this time saver lapping compound, which is a non-embedding compound, like a grit. Basically, it's a powder you put on. And the cool thing with this grit is it's guaranteed not to embed, so it doesn't stick in the plate, it doesn't stick in your part. It just kind of breaks down and gets finer and finer and finer. So I started out, I have the 2 green ones, which are for hard metals and like cast iron, and then I just yesterday got the 2 yellow ones, like fine and very fine. I'm using the coarser one right now. Okay, the time saver leaves a duller finish for sure. I did stone it, and I put a nice scratch in it right there. The diamond is a lot more crispy and shiny. But I wonder if I'm completely over engineering the requirements for this, if I'm causing myself too much grief. I could get them flat within another few hours of work. But really, the business end of this, which is this kind of rectangle in the middle, where the blade gets touched, where the blade touches, is like flat to within a tenth or two. A little high in that corner right there, but like from here to here is pretty darn flat. And I'm just kind of one-handed, not taking this very seriously. It's pretty flat. I'm gonna call it good enough and send it. We can always take them off and lap them again in the future. I think other variables to this, the heat, the fact that they're new plates, not old plates, the pump, the filter, all that stuff is going to have more of an impact than this 2/10, but we can chase this later. I'm driving myself crazy trying to chase it right now. Let's get everything else done first. All right, once again, I'm using my precision ground stones. Always dress them together before using them. These things are so awesome. I've got like 5 sets of them here around the shop, and I need more. So I'm stoning the top surface of this to make sure that there's no burrs or high spots. This is the sealing surface, so the top plate goes on top. We're going to use black RTV to seal it in place. It's funny, these ribs in the middle, they really sing. But if I go this way, they don't sing. Okay, good. Yeah, they're really good. Easton absolutely crushed these things. If you ever need parts, Mariah Manufacturing. He's in Chicago-ish, somewhere in the Midwest. Absolutely crushed them. Okay, good. So again, because these stones are diamond flattened, like on a surface grinder with a diamond wheel, they don't scratch the part. They're not abrasive. They're only looking for high spots. I can feel a couple in the corner there, just get rid of those. I'm just being kind of sloppy with this right now on video. Okay, good, and then I'm gonna clean them real good. I can feel a couple little, actually it's the step over line right there between the passes. It's a little bit high. So I'm going to go to the coarse side. These stones have a fine and a coarse side. They don't actually do any different, except the coarse side just has bigger pores for little boogers to stick into. So they can technically make the same surface finish, like the same amount of shininess. The bigger one's just gonna absorb better. Good enough. The RTV is gonna do the rest of the job here. All right, got my gloves back on. Time for some RTV. Notice how the screw holes on the top that will hold this thing down are even in between each rib, so that we get even nice coverage across all the ribs. I'm going to RTV everything and then squish it down using some 440 tiny little cap head screws. All right, this is going to be annoying. Luckily, it doesn't cure very quickly, so I got time. You don't want to put it on like tasty toothpaste. You just want a thin, even coat. All right, complete. I'm checking the first spot. Yes, it's still tacky. That's good. That pleases me. Means it hasn't dried yet. Just going through, make sure everywhere has sealant. Good. I do not want this to leak. I mean, it'll just be full of water, possibly antifreeze. Not big deal if it leaks, but I would rather it not. Good. I'm really happy with that. Okay. So I'm going to put it down. I'm going to align it. Get some hardware ready. I'm going to kind of jiggle it into place to set the RTV. And I think that's all I can ask for. So we've got this set to setting 7, which is kind of how we tighten all the handles into our knives on the fixtures. Done. On to the next. All right, I have installed stainless steel push to connect fittings. I have torqued it, I have RTV'd it, I put it all together. And then it kind of occurred to me, oh, wait a minute. As I torque these fittings guten tight, are they expanding the material up just a little bit? Like maybe, I think it did. And then also attaching this top plate, torquing it down, is that going to change the flatness of this top surface? Guess what? It totally did. This one, which was within like 2 or 3 tenths, is now more like 7 tenths because I've constrained it in a weird way. So technically, I should be lapping it again. I am not going to do that tonight, but I will probably end up doing that at some other point in time. So that's interesting. I mean, it totally makes sense once you think about it, but I didn't think about it. So, bummer. I only checked one of them, I didn't check both, but anyway, they're done. All right, I checked the other one. The business end, as we said before, in the center is good enough. It's the corners, the outside, the whole plane that's not like ideal, but I'm gonna send it for now. We can always redo it later. All right, back at it, day 2, installing all this stuff. So we have our plates, the RTV has been curing overnight, stainless steel fittings have been threaded in, and then we have all the air fittings we're going to require. I got these from Metal Air. They're a Toronto-based company, and they actually make most of these things in Toronto, like close to us, and I really appreciate supporting local whenever I can. So we're going push to connect for all the hoses, And then in the other shop, let's go there and figure out what else is going in. So we used to use these little aquarium pumps. How many gallons per minute? 180 gallons per hour. 2 of those, one for the bottom plate, one for the top plate. We are upgrading to this beautiful diaphragm pump, Pentair SureFlow. There's the part number. This thing moves 3 gallons per minute, which is not an insane amount of fluid, but at 45 PSI should be awesome. So we're gonna have one pump with a Y fitting to feed the 2 plates, bottom, top. It's got plastic fittings on it, so I got these JIC fittings, which our local plumbing supply store said will seal onto the inner tapered bore of that. I don't know if you can see it. Taper, cone, so that should seal. And then we get push to connect on both sides. Push to connect all of the things. Hose barbs are dead to me. Now these are plastic fittings, so I do not want to go silly tight. Use discretion. I'm gonna call it good there. I actually don't like how the threads are molded into the thing, so if that plastic breaks, the whole pump, or at least the whole top cap, is dead. Gently. Trying to gauge evenness between the two. Okay, should be fine. Ooh, this thing's serious. Not bad. All right, look at this thing. It's a pretty nice little unit. It was actually wet on top, and I'm like, that wasn't me. So I pulled the rubber caps off, and the thing has water in it. So I'm pretty sure this is just a coil in and out, and then inside is where the condenser and everything happens. So your water is just kind of a sealed circuit in and then out through a titanium coil, which kind of makes it useful for acids and other weird things, salt water for aquariums. That's kind of what it's marketed for. But I think it's going to be absolutely killer for us. Came with a bag of fittings, so we're going to hose barb here, which I don't love hose barbs, as I just said like 30 seconds ago, but we'll figure that out. All right, sorry about the extra noise. We got the tumblers on in this room. So the question becomes, do we run the 5-gallon bucket through the pump and then through the chiller and then to the plate? Or do we have 2 separate circuits where we have a pump that goes pump straight to the plates and then back to the bucket, and then a smaller pump that goes from the bucket to the chiller and then back to the bucket, so that the bucket is just getting chilled constantly, and then the quench plate side does its own thing. I think because of these hose barbs, I'm gonna have to do that. So I'm just gonna run a hose from the tank to the chiller and then back to the tank, and then let the pump with all the push to connect fittings do that job. So we're gonna reuse one of the aquarium pumps, this guy right here. And I was just playing with the flow rate on it, see what she does. It does move good water. So that's gonna feed the chiller. Looks like today is a double batch day. So we just bought ourselves 25 minutes. Okay, here's where we're at. I got the chiller plugged in. I got hose barbs, going to an aquarium pump. I took one from our existing setup, so our existing setup is now dead. So an aquarium pump pumps to the chiller pumps back, exits right here. And then I have a push to connect line zip tied to the pump. So that's gonna suck up to the diaphragm pump. And then once Sky is done there, we have to run a hose to the plates. We have to install the new plates. We have to put water and antifreeze in here and then start chilling. Ideally, this would have been chilled for like 2 hours already, but let's see what we can do here. So when it comes to the plumbing and the routing of the lines and stuff, I'm trying really hard not to have, do a bad job, but also the other side of me goes, this is proof of concept. I need it to just work. We can clean up the plumbing later. The problem with that is sometimes you never get around to cleaning up the plumbing later. So I think we're gonna have to, but it's gonna be good enough for now. Okay, the old setup. The top plate is attached via 4 button head cap screws. So we're gonna pull that off. New plate will bolt right onto that, no problem. Bottom plate is just kind of sitting there on 3 dowel pins. So it looks like a 1/4 inch dowel. One goes in a little hole in the back, and the other 2 just sort of rests in between that. Good enough. So I gotta find some dowel pins and put them in the new plates. So here I've got my Gridfinity bins with all the cap screws and nuts and everything. And these are the only dowel pins I have. They're shorter than I was expecting. These holes are probably the entire length of this pin. However, the hole is undersized, so I'm gonna have to press them in. So I don't have longer pins that would like stick out perfectly. So I'm just gonna gently press them in, use an arbor press, gently press them in a little bit. This is a non-critical application. All right, it went in a little bit. Perfect example of another improvement we made. See how on the original ones the fittings go straight out the back and they rub on the frame right here. So we had tape and it was just not ideal at all. So on the new ones I added this bump out so the fitting can just go straight back. Very nice. Okay, bottom plate's on, just got to get the top plate. I got to unscrew these 4 bolts. This guy is now bolting on the top plate.
How well do you think it's just going to slot right in?
Better be perfect. We're running all pumps, all chillers, all lines. I don't think there's any leaks. We had a leak in the beginning.
There's a considerable amount of activation in my bucket.
Yeah. So we had a leak. This guy cleaned it up for now.
It has a lot of rotation.
Yeah, I don't know why the old one didn't rotate as much. The hoses.
These lines stopped it from rotating.
Interesting.
It bumped the sides. So it had a little bit, but this is considerably
Yeah,
more.
So we'll figure out a way to restrain that.
I think that bolt is tight in there too.
Yeah.
Underneath. Because I tightened it and it wiggled last time.
But okay.
Let's do the thing. You can see where it smushed that.
All right.
Like, that's a really good sign.
Well, I already see a mark. Getting our consistent pressure. Cool, we're gonna run through and see what we got.
85 when we're done, something
All right,
like that?
8th blade, these things are room temperature. They're actually a little bit cold.
70 degrees, 69 degrees.
That's cold though.
Yeah.
Used to be warm. Used to be like very warm.
So all the heat actually did go in the cooler.
Yeah.
Like it's designed to.
Interesting. So, I mean, before we used to have temps go up to what, 85, 90 after 8 blades?
Yeah.
And now we're at 75.
76.
76 if you're,
76 at the reservoir, not 76
at the plate. And the plates are constantly getting cooled water. I don't know, this is really good progress. And the plates are flatter, and the cooling channels on the inside are better. And the proof is in the pudding. There might even be further like minor tweaks over time. All right, after 8 blades, we see some marks, some, they're not even dense. I cannot feel them with my hand at all. And then, like I said last week, we got these stones from Kinetic Precision. Dress them together, clean your plates off. That's gonna clean any high spots off. Couple tweaks, we're gonna have to constrain the rotation of this. The hoses on the old one used to keep it in place.
I mean, if you saw one, it was actually at the bottom of the stroke, it was centered every single time.
Yeah, Sky did a really good job.
It looks a little funky at first, but
trying to lift up the bottom plate, bringing together. But they turned out really, really good. You can see kind of a light spot in the middle where it's squished through the oxide, the blackness. So that blade a little bit heavier here maybe, but this blade, you know, from what Sky experiences doing this every day, that looks flat to him. But the proof is in the pudding. We have each blade numbered 1 through 8. We'll track them through, and maybe we'll measure flatness on some of them. Maybe not in this video though. So now Sky's getting the first batch of Rasks were not in this new setup, they were in the old setup. And then the Norsemen will go through, they'll get tempered, 2 cycles, cryo, all that stuff. So for the moment, for the past 2 days, Sky is using the cant twist clamps to secure the fixture while he tightens the bolts in a nice pattern, which I like the thought of better than just tightening the bolts by themselves. We're not quite to the point of putting the cant twist clamps in the oven yet. Somebody made a great comment about the zinc layer burning off in the oven and, you know, killing you with fumes. Very good point. Appreciate tips like that. We thought about it briefly, but always good to have corroboration.
They definitely get tight.
Good. And it's a copper-plated steel screw, even though it looks like straight copper. Everything's copper-plated, zinc-plated, so. That oven is not red hot. It's only 400 degrees.
Like making pizza.
So the chiller's still at 75 after 10 minutes of being done chilling, or heat treating.
It's dealing with the bulk of the heat now, right?
Yeah.
After it's all equalized?
Step in the right direction. The other thing we could do is a bigger bucket. Saunders reminded me, that's the cheapest, easiest way to dissipate heat faster, is just more liquid.
Yep.
So that's 5 gallons, not even, probably 4. If we do 10 or 15, yeah, like that guy, or something like it, just, it won't rise as much because we're only pumping in so much heat with 8 blades. So on our pump, we did have a leak at this threaded NPT section. So if you remember a little bit ago, these fittings had the pipe tape already on them, like the painted on kind, which apparently was not enough because there's a bit of water right there. So this guy's gonna have to take them apart, re-pipe tape them, put them back together. They should be good to go. Although I'm glad my plastic side didn't leak. That's really good. So when you unbolt those, be careful that you don't
I'll wrench on the
break the plastic.
The non-plastic side.
I made them tight.
Okay.
You might feel more comfortable unbolting this and doing this on the bench.
That's probably a good idea.
So here we have our Y fitting to, this is kind of interesting. I did 2 sets of ball valves in each line. That way, when I shut off both ball valves, we just have to deal with the liquid in between, and then we can keep the fluid in the plates if we want to like remove the plate fully. Although since we have a diaphragm pump, we can just pump air through the whole system, and that's not that big of a deal anyway. Yeah, Sky's got the inlet lifted up, so he's just pumping air through the system. It worked great. So now for the most part, to get rid of that leak, he's drained the system with air. I love it. Unfortunately, I don't think we'll have any data for you guys, like how flat the blades are, but maybe we'll do a catch-up video at some other time.
We'll have to do something once it's all kind of figured out.
Yeah, I think so.
Better results.
Final upgrades kind of thing. But man, we pushed it today. We got it installed. Just in time for that second batch, like minutes.
Yeah.
And no major leaks, so that worked out really well. Good, I'm happy with how this turned out. Very, very happy. All right, guys, stay tuned next week. Bye.